Hey Pre-Algebra guys, we are jumping in today with 8.3. This is applying equations. So some of the information that we've had and used will be applied, and we'll have to do some reading and determine things as we go. So let's jump right in. I hope you have your interactive notebook. Take some notes. If you guys are running out of space in your interactive notebook, feel free to take notes somewhere else. I would suggest that you find one place that everything could be in one spot so that you're organized. I know that we also don't have a new table of contents, so it's not ideal. We're just going to kind of make it to the end of the year, but if you put your notes and label it clearly, hopefully you've built up enough skill sets from earlier in the year to have some notes that will be helpful for you. Okay, so this is applying equations. We got to look for our keyword is. When you see is, that's going to mean, hey, put an equal sign in, and we're just going to kind of break it down. Sum means to add, less than means to subtract, but for more of these words, go ahead and look at 2.6. We have some notes from there, and we did a bunch of words and processes and determined what words would be helpful. I know you don't have that big picture that's up on our wall that has like the plus, minus, subtract, add, that kind of thing. But anyway, make the best with those words. Do what you can on that. All right, let's just jump right in to do some examples and go from there. Okay, so example 1. I am going to ask that you follow along in the book. I tried to write all of this out on my screen, and you know what my handwriting looks like on this thing, so it was not legible. But I will write the page number. So on page, 323, this is example 1. So pause the video if you need, get your book, have your notes, and jump into example 1 with us. So it says, find a number such that 5 times the sum of that number and -3 is less than the opposite of the number. Generally, when you read the first problem, or any problem, the first time you're going to feel that it's overwhelming and that it makes no sense. So just break it down. Don't be overwhelmed by it. Do little pieces at a time. And when you eat an elephant, you eat it a little bit at a time. I don't know if you've ever heard that. You can do anything if you just do little bits at a time and kind of fight through those little parts of it. Okay, so find a number. That means we're missing some information. So I'm going to call that number. I'm going to say let n equal that number that I'm looking for. Okay, so it doesn't have to be n. I'm using n because it says number. If you like to use x, stick with x. If you want to use the letter of your name, go for the letter of your name. Okay, find a number such that 5 times the sum of that number and -3. So let's just pause there, because the next word I saw was is, and that makes me think equals. So I'm going to just focus on that first side. 5 times, okay, so I know I'm going to multiply 5 times something. 5 times the sum of that number. Sum means to add, right? If I see sum, I'm going to add. And I want to add that number plus a -3. Okay? Now, why did I put it in parentheses here? Well, I'm multiplying everything in there. 5 times the number, the sum. 5 times that sum. So here's the sum. And I want to have 5 times of the whole sum. So that means I'm going to need to use parentheses so that I know to use the distributive property later, because it's 5 times everything. You have to add them together first. Okay, so I'm going to kind of rewrite it down here so we can see it more clearly. 5 times, and I'm going to drop my dot because we know that just using parentheses will mean multiplication. If you like the dot there, you can go ahead and keep it. Now, I do also know that when I add a negative, that's the same as subtracting. So I'm just going to kind of simplify it up a little bit and make it look like this. Okay, so 5 times the sum of that number and -3 is, as soon as I see the word is, I should think, hey, is, let's get my other color, is something that's my keyword here, meaning equals. Okay, is 3 less than the opposite of the number. Okay, 3 less than, if something is less than a number, I have to start with my number and subtract 3 away from it. I don't start with 3 and take it away. Think about that. If you had $3 less than the person next to you, it's whatever they have, and then subtract 3 less than. Okay, so stop, turn it into money between you and somebody else, and hopefully that'll help you kind of process that. We really do think about things well in money. I don't know if that's a good thing or not, but we do. Okay, so it's 3 less than the opposite of the number. Okay, well, I know that the number is n, and it's the opposite of it. So the opposite means if it's positive, I need to make it negative, and if it was negative, I need to make it positive. Well, right now, my n is just regular n. It's just positive, so I want the opposite of that. Okay, all that work just to get here. This now is my equation. And then once I've written the equation, I still need to solve it. But at least I wrote my equation. Okay, so let's go ahead and solve this. We are going to need to apply the distributive property here. So we'll kind of write this out. This should be a review from before Easter. I hope you had a good Easter. I didn't even talk to you guys about that. So sorry. Goodness gracious. Send me a picture of you doing something at Easter. I'd love to see what you guys were doing and up to, and hopefully got some extra sleep and enjoyed not working on schoolwork. Okay, so if we multiply by 5 all the way through, I'm going to write it out this way. It's kind of a simplified. Remember, the first thing to simplify is to get rid of my parentheses. So I want to make sure everything in here, the sum of it, or the difference in this case, is multiplied by that 5. Now that I multiplied it by that 5, I can simplify a little bit more. And remember, I'm solving for n. That's what I want to know. I'm trying to figure out, hey, what is n going to be? Well, I have n on both sides, and I don't want it on both sides. I also have some constant here on both sides, and I don't want that either. So I'm going to combine my like terms and kind of move them to their own side of the equation. If you like to still draw your line down the middle to make sure you have a balance and keep everything equal on your balance, right? You got to keep everything the same on either side. Go ahead and do that, but that's up to you. All right, so I'm going to combine here and move my n to the left side. You guys remember that I like to do that. If I have a negative n, how do I undo a minus n, or an opposite of n? Well, I'm going to add it, right, so that this will cancel. If I do it to one side, I better do it to the other. All right, so now I have to combine these two. They're like terms. So 5n plus, remember, this is like an invisible 1 here. If you have 5n's plus a 1n, it's 6n. And then just rewrite everything. Keep it the same, and then we can address the rest. Okay, now I still have this little guy here, and I want to make sure that I move him to the other side, and I can't just scooch him over. That would ruin our equality, right? We got to keep it equal. So let's get this out of the way here. All right. If I'm subtracting 15, the opposite of that would be to add it. Remember, we do opposites to get rid of something on this side. And if I do it to both sides, now I have officially moved my 15 to the other side by getting rid of it on this side, okay? All right, so then that's going to give me 12, and I'm still looking for my n. Right now it is being multiplied. To undo that multiplication, I will divide both sides by 6. That means n equals 2. There we go. We found our number. Way to go. Give yourself a pat on the back. Okay, I want you to look at skills check 1 right now, and I want you to try just the first one. So skills check 1, and I want you to try number 1. So pause the video and we'll come back and check it together. Okay, so it said the sum of 2 times a number and 3 was my equal sign, is half the number. Okay, so you had to write the equation and then you had to solve it. So start with all the words that are before is. If this is my is, and then there's words after it. It said 2 times a number. So I'm going to use X this time. You can use whatever letter you want. 2 times a number, right? It's some number times 2. And 3. Well, if I had $5 and $3, I can put it all together and say I have $8. So what I'm really doing is adding. So and 3 is, that gives me my equal sign, half the number. Well, I still know it has to be the same number, so I'm going to use the same variable, but I only want half of it. Of means to multiply, so I can write it like that. There you go. That's your equation. Now I had to solve it. So when you solve this all the way through, you could move your x's probably to the left or to the right side. It would be a little bit easier, but remember we talked about how you can do either way. I'll just get a 0 on one side. So we would, if we subtracted a half x from both sides, if you want it on the left, this is, again, I'm showing you the not easier way. 1.5x plus 3 equals 0. Subtract 3. 1.5x equals negative 3. Divide by 1.5. And you should get x to equal negative 2. If you were to, remember, if you were to divide this out, negative and a positive, when you divide, it'll still be negative, and you'll have to move your decimal over, and it goes in 2 whole times. Okay, I hope you did well on that. Let's jump to another example. All right, I did try to write this one out for you. All right, consecutive. Consecutive is a key word that's really important to know. If you have something that's consecutive, it means right after each other. So if you have a lot of kids in your family, if you put yourself in consecutive order, the oldest would line up and then all the way down to the youngest. So if we're talking about consecutive integers, if I say 1, 2, the next would be 3, 4, right? These are consecutive. If I said consecutive even numbers, 2, what's the next one? That's right, 4, 6, 8. It just means the one right after it. So it's not necessarily a pattern, although I suppose there is a pattern involved anytime you have a consecutive something. If I said consecutive odd numbers, I would say 1, 3, 5. They just, if you follow what's happening, it's whatever's next. So in a way, it is a pattern. So mostly we talk about consecutive integers. So you could have a negative 1, and the next number would actually be a 0. So kind of going through that way. Anyway, so that's what consecutive means. Okay, this is example 2 on page 324. Okay, the sum of 2 consecutive integers is, keyword is, make sure you think equal sign right away, 173. Hey, I already know that here's going to be my equation. I know it's going to be equals 173. The only thing on that side of the is 173, so that's really nice. But the other side's going to be a little bit trickier. So I have 2 integers. That means they can't be the same number like they used to be. Consecutive means one's right after the other. So in the past, we could use one variable if we refer to the same number, but we have 2 variables. We have 2 different integers that we're looking for, but we don't know how to do it yet with 2 different variables, nor would that actually help us in this case. So we've got to think about, I've got x, let's just say it's the smaller integer. Well, whatever's the larger number, right, I'm going to have a smaller number and a larger number. Okay, well, the larger number or integer is consecutive to the other one. So if x is 5, what comes next? If we're not skipping any because they're just integers, they're not odd or even. Well, 6 would come next. What if I gave you 10? What would be next? 11. If I gave you 15, what comes next? Of course, 16. What happens every time? We're just adding 1, right? So couldn't I say that the larger one is whatever I start with plus 1, right? So what I have here is I have both of these. It says the sum of those 2 numbers. So if I take x and I add it to this down here, I should get 173. So I'm going to say x plus 1. You don't have to have parentheses around that. I'm just showing you that this is like our larger integer and this is our smaller integer. Okay? Well, because they're joined together with an addition sign here, I can really drop those parentheses. I'm not distributing this x. It's not being multiplied, it's adding. Okay? So I can just put those together. They're like terms right here. I'm going to rewrite this. Let's get rid of some of this for you. Let's rewrite it a little bit more simplified. The first thing would be I could drop my parentheses. If I have 2 x's, I really know that's just 2x plus 1 equals 173. Again, you're rewriting every step. You could draw your line down through your equal sign. All right, I'm going to subtract 1 from both sides. Gives me 2x equals 172. Now I'm looking for my x. It's being multiplied right now, so I'm going to divide to undo it. Okay, so x, we run out of space, x is going to equal 86. Okay, that's my smaller integer. What does my next integer have to be? Well, if I know I have 1 is 86, you can come back here and say, I'm going to add 1 to it, or you can just say, yeah, I know what comes next. So what are your 2 numbers? Your 2 numbers are 86 and 87. All right. Let's do one more example, then I'm going to give you a skills check. I have one fourth example and a third skills check, and you'll be done. All right, number 3. You should be on page 325. Find 3 consecutive odd integers. So I'm just going to pause there before we do anything else. Odd integers, that means if I had 1, then I would have 3 next, then I would have 5, then I would have 7, then I would have 9, right? So instead of adding 1 like I did over here, I'm actually adding 2 every time. Whether they're even or odd, you're always going to add 2 every time. Just depends on what you start with, okay? All right, so I have 3 of these now. So I'm going to have x equal my smallest number. And then x plus 2 would equal my middle number, or the next largest, I guess I should say. The next largest in the consecutive numbers that I have here. Okay, now this is going to be x plus 2 plus another 2, right? If I'm adding, and then I have to go again, like it could be a 1, a 3, and a 5. Or a simpler way, instead of saying x plus 2, what could I actually say? Say x plus 4, right? That's going to equal the largest odd integer. Okay, sorry, that's about as messy as it gets. Okay. All right. Well, then let's take a look and break this down a little bit more. Here's my keyword is. I know that's going to be my equal sign, so all the words before it will be on the left of my equal sign, and all the words after it will be on the right. So let's take a look here. Okay, so I have 3 consecutive integers. 3 times the third. I'm going to start here because this is just kind of stating what I have. 3 times the third, oh, I'm sorry, your book says such that. So insert here is a such that. Such that just means like, hey, this is what I have, but this is what I know about it. So find 3 consecutive odd integers. That's what I have. Such that means, and I know that they happen to be 3 times the third is 2 more, etc. Okay? All right, so 3 times the third. Well, here's that third one, right? So the third is actually this. So I'm going to say 3 times the third number. Now remember, your parentheses are crucial here because it's not just 3 times x. That would actually be 3 times the first number. I want 3 times everything inside parentheses. I want 3 times of that first number plus 4 because I have to go 4 up from whatever number I was at. So 3 times everything in parentheses. That's really important. Is, keyword, right? Make an equal sign. 2 more than 5 times the first. 2 more than 5 times the first. Now with adding, it wouldn't matter. You could put 2 more than 5. Okay, what's the first? 5 times x, right? 5 times x. I don't need parentheses there because I'm just have x. I don't have anything else around it. If you want to put them, you could. Now, another way you could put this is you could say 5x plus 2. Because you're adding, it doesn't matter which way you have them. All right. Subtraction would matter right there. All right, let's keep going then. Now let's simplify, and we're going to want to use the distributive property. And we should get 3x plus 12 is equal to 2 plus 5x. Now I've got to put my x's together, and I've got to put my constants together, and I want to put them on opposite sides so that I can solve for x. This is a review from before. I know this is still fairly new stuff though. So anyway, all right, let's see. I like my x's on the left, so I'm going to take it away from the right. If I do it to the right, I have to do it to the left. I'm going to combine these together. I get negative 2x plus 12 is equal to 2. Now I'm going to take my 12, my constant, and move it to the other side. If I'm adding 12, I have to do the opposite. Do it from one side, do it to the other. So this is going to eliminate, and I get 2x, negative 2x equals negative 10. Remember, if you have a positive and a negative, you're going to subtract them and keep the sign of the quote-unquote larger one, the sign of the one with the larger absolute value, technically. All right, now I'm solving for my x, and it's being multiplied, so I need to undo that with division. And if I'm dividing a negative by a negative, I'm going to have a positive number. So x is 5, but is that what I actually want to know? Not really. I just want to know what are my three numbers. So I could plug them in here, and I could say, hey, this is 5, and this is 5 plus 2, and this is 5 plus 4, which would give me 5, or you might just be able to recognize the pattern and write it down, okay? 5, 7, and then 9. Those are my three consecutive odd integers. All right. Oh. So let's do skills check 2, number 1. Okay, skills check 2, number 1. I want you to pause the video and try it by yourself, and then hit play. We'll go over it together. Okay, how'd you do? Number 1 said to find two consecutive integers whose sum is 91. Well, if they're consecutive and it doesn't say odd or even, I'm going to have an x and then I'm going to have an x plus 1, right? And I'm going to have to add those two together and get 91. So what I'm going to have is x plus 1 equals 91. So 2x plus 1 equals 91. This would be a good equation right here. Okay, I'll take either one. And you could have had parentheses around that as well, but this is most simplified. Okay, so now you have 2x equals 90. So once you divide, x should equal 45. Now, am I done yet? No, I need two consecutive integers. So my real answer is that I have 45, and then the next number would be 46. Again, could you plug in the 45 here plus 1 and say it's 46? You sure could, but you probably can figure some of those out without having to plug it back in. Alrighty, last example. If a ship is traveling 20 knots or nautical miles per hour, how long will it take to travel 55 nautical miles or nautical miles per hour? Don't worry about understanding those units unless you do a lot of sailing. You can think about it as just miles per hour like you're driving. We're going to mostly look at the numbers. And what we want to do is use our formula distance equals rate times time. You're going to need to know this for your assessment next Friday. Again, you can use your notes. You'll have to identify which is the correct equation. Okay, so let's just kind of plug some stuff in. We are going to be given two variables that we don't know, and we'll be looking for one. Now, it says how long will it take? I already know that I'm probably not going to have time. I'm looking for time. It's how long it will take. So I'm going to be given my distance and my rate. So my rate is some miles per hour, generally speaking. If you're driving down the road at 60 miles per hour, you can figure out how far you go, distance, based on how long you drive, okay, assuming that you keep the same speed the whole time and that you're on a highway for 60 miles per hour, right? Okay, so if a ship is traveling 20 knots or miles per hour, that right there, miles per hour, shows me, okay, 20 has got to be my rate, okay? So 20 is my rate, and I know that I'm looking for time because it said how long, and how long will it take to travel 55 nautical miles? Well, how long will it take to really go 55 miles? Again, even when I do these still, I'm not familiar enough with nautical miles that I kind of just jump to pretending it's just miles and miles per hour, okay? All right, well, now I have an equation here. I have 55 equals 20 times t, which I can just say is 20t. Well, if I'm looking for t and I'm solving, something's being multiplied, I'm going to need to undo that by division. So divide by 20, divide by 20. Your time is going to equal 2.75. Now, is that it? Can I leave it like that? No, I need to know what kind of unit goes with that, okay? And if it says miles per hour, I'm going to know that my time is going to be given in hours because that was the rate that I was given. So my full answer would be 2.75 hours. Okay, well, I want you to flip the page to 326. Try skills check 1. Skills check 1. Okay, skills check 3, number 1. If an Olympic sprinter runs 100 meters in 9.5 9.80 seconds. What is his average speed? Well, average speed might be a little bit hard to understand. Average speed means how many, I guess in this case, meters per second does he generally run? That's going to actually be my rate. So when I hear average speed, I can consider that to be some rate of speed. How, what's in general, how fast is he going? Okay, so I know that he runs, well, let me write my formula out first. Oops, I think I did that in yellow last time. Distance equals rate times time. Okay, and I know some different things this time. I'm looking for R. Okay, I know that he went 100 meters. And that's going to equal some rate that he's going to go on average. And I do know that he ran it in 9.8 seconds. Okay, well, if I'm looking for this R here and it's being multiplied, I'm going to undo it with division. So if I undo it with division, and I wanted you to see here that I still left the units there so you can see what's happening with the units. You'll learn more about that in science and later on, but for right now we're going to know that our rate is going to equal 100 divided by 9.8 should give you 10.2, and then what's left over is meters per second. See how that line here? It's kind of like this line here, and it means per or for every, like a form of division. Okay, so this is going to be your rate unit. Is not miles per hour, it's meters per second, and you should have 10.2. If you had 10.20, that's fine also, because you might have had a 0 here. It doesn't really matter. Those zeros don't make any difference. Okay, awesome. You did a great job. I hope you feel like you're understanding this. Again, feel free to go back, watch it however many times you need, and jump to your homework. You should be able to check it tonight, and we will do 8.4 tomorrow.